Okay, so this lecture is about string matching. The idea is that I have a string text T and I want to see if the pattern P occurs in that string or not. For example, does the pattern 101 occur in this long string text? Or does the pattern ABC occur in this long string text? A simple way to do this is to consider different shifts and to start from the first and see from the first element and see if starting from this element I can match the rest of this pattern with the next few elements depending on the length of this text, right? So let's demonstrate that idea. The way we do that is as follows. Let's suppose I have this text 11001011 and I want to find whether this pattern 101 occurs in this list or not. The simplest way is just to start with this text 1101011 and check whether these three elements make up 101 or not. First element matches, the second element does not match. So this pattern does not match with the first three elements. Let's move this pattern a bit to the right and check whether it matches with these three elements. If I check these three elements 101, this one matches, but this one doesn't matches. And the idea is that I keep on repeating this process up until I find the right text. So first I check these three elements, then I check these three elements, then I check these three, and then once I check these three elements I know, and if I match them with my pattern, then I see that this pattern is the same as this pattern within this long string text. And how do I report this? The idea is to talk about when does my pattern start in my string. So I can say my pattern started not at the first, second, third, fourth. It started at the fifth position. Or you can also call it the shift. Right? Now, how do we write an algorithm that takes this entire procedure that we just did and translate it into a code that a machine can perform as well? So now let's look at the code. Here is the pseudocode for the naive string matcher. It's the same process that we just did, but the idea is now to follow this algorithm and see if it does the same thing as we did. And instead of going through the algorithm, let's just assume that we're a machine and let's just follow these steps one by one. How do we do that? Let's start. So this is my algorithm. Let me just resize this a bit. Okay, this is fine. Alright, so let's start my naive string matching algorithm. So the procedure requires two inputs. The first is the inputs for this algorithm are my string T, in which I am trying to find the pattern T1, T2, T3 up until Tn, and my pattern P, which is P1, P2 up until Pm, and the assumption is that M is less than or equal to N. That is, the length of my pattern is smaller than the length of my text. You should think about what happens when M is greater than N. That's something for you to think about. Okay, let's follow my procedure. My procedure tells me that I start from S equals 0 to N minus M. So I start off somewhere in memory I'm going to store the value of S, and I started off by 0, and N minus M just to make sure what my T is. So the input that I'm giving it is 1 1 0 0 1 0 1 1, So this is my t, and so n would be 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. And pattern P is simply 1, 0, 1, so m equals 3. Therefore n minus m should be 5. So as I enter this for loop, I will start off at 0, but I will stop at 5. So I should stop at, my last value for this one will be 5. I'll just put that somewhere here. This is where I'm keeping my value of s. Okay, now we have the value for j equals 1. So let's set j equals to 1, and I start off a loop. Let's see if I get into this loop or not. While j is less than or equals to m is 3, so j is of course less than or equals to m. I will enter this loop. No, I need to check this condition as well. Ts plus j equals to p of j. So I need to check this, by the way, is p. So I need to check whether is ts plus j equals to pj, which is, I enter my value of s, which is 0 right now, j is 1. So I check whether t1 is equals to p1. This is t1, this is p1, they're both equal, and now I need to enter the loop. The loop tells me to start j as j plus 1. So now I increment the value of j becomes 2, and then I check whether I still am in this loop. M is 3, so the first condition is satisfied. The second condition is, I need to check whether t2 is equals to p2. t2 is this, p2 is this, these are not equal, therefore I will not enter this loop and I will exit this loop. And this is saying, if now I check this condition, if j is greater than m, well, is 2 greater than 3? No, this if condition will not be executed. And then I move on back to the for loop, and now I can finally increment the value of s. So s is no longer 0, we have s equals 1 now. Again, j starts from 1, m is still 3, and now I will check whether ts plus j is equals to pj, which is now s is 1, j is 1, so I will check is t2 equals pj, p1. So let's write down the string again, 1 1 0 0 1 0 1 1, and what's happening is t2 is being compared to p1, so p is basically being placed here, and I'm checking whether t2 is equals to p1. This is true, so I enter my while loop and I increment j equals 2. I again check both the conditions of my while loop. This is still not satisfied, but this, let's check now. ts plus j should be, s is 1, j is 2, therefore ts plus j is t3 equal to p2. Both of these are equal, this is satisfied. I move to j equals 3. I check these conditions again. Is t4 equals p3? t4 and p3 are not equal. I will not increment my loop and I will move to the next line. Again, the if condition checks whether j is greater than m. j is 3, m is 3. This is not satisfied. I will not execute this if loop. So you can see what's happening. Now if I change s is equals to 2, my first element of the pattern will be compared with the third element of this text. So let's complete this algorithm. My text was 1 1 0 0 1 0 1 1. This was T1, T2, T3, T4, T5, T6, T7 and T8, and my pattern was P1, P2, P3, 1, 0, 1, and I had reached S equals 2. You can see that if I keep running this algorithm, I will never enter this until I reach the point when my S is equals to, let's say, 4. When S is equals to 4, let's see what happens when S is equals to 4. I'm assuming you can work out what happens at S equals to 2, S is equals to 3. Just follow these steps. I'm just going to move on to S is equals to 4. So S is equals to 4, J equals 1, and I have N equals 3. I will check my while loop again while J is less than or equals to M. TS plus J will be checked with PJ. So TS is 4 plus 1 will be compared with P of 1. So T5 will be compared to P1. T5 is compared to P1. This is correct, so I move to J equals 2. Then T6 will be compared to P2. These are same, therefore I move to J equals 3. These are still same. T7 is same as P3. I increment J to be 4 because again my while loop conditions were satisfied, and so J is finally 4. And now if we check J greater than M, this is true, I will finally execute this if condition, that is S is a valid shift. So the program will output the following: 4 is a valid shift. And so the idea is that if you start off with the string, and if you shift 4 places, 1, 2, 3, 4, if you start checking from here, then the pattern will match, and it does. So I get S is a valid shift, that is 4 is a valid shift, and that's my output of the program. Of course, if you notice that there is nothing that stops my program from stopping, so my program will check the rest of the string as well. So my program will execute S is equals to 5 and see if it finds any other valid shift. So for example, if you go on and if at the end of the string you had another pattern 1, 0, 1, then when S reaches 5, 6, 7, at S is equals to 7, my program would have also outputted 7 is a valid shift. So I'll get two outputs. One is 4 is a valid shift and 7 is a valid shift. So this naive string matcher checks all the possible shifts and outputs all the valid shifts that it can find if the pattern matches exactly with the pattern P.